Okay, so welcome to the part 2 of this physics practical update by the Young Modulus Solutions. And of course, if you are here in this YouTube channel for the first time, I provide solutions to physics, mathematics, and of course practical courses. And this is second semester physics practical, okay, materials, concepts that will be done in this second semester. Basically, of course, here for all students, but the University of Port Harcourt students are very close to me around this vicinity. So I'm also working to ensure that everybody get the best out of it. So basically, I shared with us last semester marking guide, but many of you were not in that class, so I just have to do it again. So in case you missed the last work or first semester work, so the marking guide for your physics practical, I'll be sharing it fully, okay, when I start the main work. But just have it that the major thing that they are going to be observed, okay, they say the thing they look at for in your physics practical is, of course, the marking guide. What they look at for the title of their experiment, title of their graph. When you come into the graphing aspect of it, okay. But of course, before you talk about the graph, you're talking about table of value. So the table of value, which is observation, what you have observed, okay, the readings you've calculated, of course, to a main decimal place. Normally, some will tell to 2 decimal place, some will tell to 3 decimal place. But normally we do it to 2 decimal place. But what you use calculator to press, when you divide with calculator, normally we put it to 3 decimal place. But what you measure directly from the measurement instrument, most time is given in 2 decimal place, as the case may be. So these are what they look at. They will look at a table of value and ensure you don't use TPEX, you don't cancel, you don't claim, you don't cancel. Ensure that their work is neat. Their table of value should be neat, and that's why you are advised to get your laboratory notebook, where you do the copy work, you copy the rough work, then later, once it's being checked by the lab technologist, you can now, when it's being verified that to be true or to be correct or to be accurate, you can then transfer them to your table of, to your manual, so that there wouldn't be any kind of cancellation at the end of the day in case they see that the work is not okay. That's what you're supposed to do. But sometimes they are very busy, so they may not really have that time to check some of these things sometimes. So, but that is the best, that is how it's supposed to be. Alright, so that's one of the things you must look at for. Your observation must be proper, and that's why, you know, if you are not being guided on time before the practical session, you may not actually know that you are right or you are wrong in whatever thing you are doing. You understand? And that's why every experiment you do have a standard. For example, you are doing verification of Ohm's law, you are measuring voltage and current, and you are dividing voltage against current to get your resistance. So your resistance. The resistance is supposed to be constant all through. Do you understand? It's supposed to be constant all through at every given voltage and current you apply. Yes. So now all those things are the observations, things you need to know. But when you now do this thing and you don't have any idea or previous knowledge about this, you end up doing the wrong thing. And once you leave that lab, there's no how you can correct them except you have to manipulate. And that's where students come to me and say, "Sir, what should I do? What will I do?" The rest of them. So those ones are outside here. Okay, I will discuss that. So, but I'm just going to give you a typical things or the major thing you are supposed to be doing in the lab session. So, like I said, number one, the table of value has to be proper, has to be accurate, has to be online. Okay, like in line. I mean, on whatever thing you are doing. Then once you are done with that, the next thing you will be expected to do is for you to plot your graph. So one of the things they look at in while you're plotting your graph is the title of your graph. You are plotting a graph of voltage against currents, a graph of what V against I. Okay, I'll be doing practical videos on this. Okay, but I'm just giving you a general tip on your physics practical stuff. Okay, a graph of V against I. Okay, that's the general stuff. Graph of V. Of course, the V must go with the unit, which is the voltage. V bracket V, which is the voltage. Then I bracket A, which is capital letter A, which is what? Ampere. Okay, so then that is number one. The next thing again that must follow, which is the major challenge most students have, and I have a request where I'm going to make a video on that, and that is what scale. The scale of the graph. 2 cm against SO units, 3 cm against SO units. You must know how to do this. Normally in the class, I don't teach students, I don't teach general class on scale because everybody have challenge on scale. But I'm going to make a video, like 2-3 videos, okay, on scale, how to choose scale. I will use different 2-3 table of values to do scale, then see how students can always go there to read and see how they can work on them. There's just a particular concept you need to grab. Once you get it, you can use it to work on any table of values of your choice. You understand? So you don't need to cram it. You understand? So that's number one. So number one I said is the title of your graph. Of course, it's very important. Then number two is your scale. Of course. Then number three is what? Labeling of the axis. So if you say graph of V against I, then your V, what does it mean? Your V should be on the vertical axis, okay, the y-axis, which we all call it y-axis, okay, vertical axis. Then your I should be on the what, the x-axis. So if you look at the board there at the back of you, that is the vertical, and this is the what, the horizontal. Okay, so you can see it there, up there. Okay, the vertical and the horizontal axis. I didn't plan to do this now. Like I said, I will be doing a video on these aspects later. So I have this and this. So y here, x here. Okay, so you have the y-axis, you have the x-axis. But since we are plotting V and I, so this is going to be V against, okay, I. Of course, the unit must be included. The unit must be included. All right. Then, of course, this is your origin. The origin must also be indicated at the end of the day. Then the next thing again is consistency of your scale. Your scale must be consistent. What I mean by consistency of your scale? If you say 2 cm to 4 units on this V axis, then it must be consistent. So every 2 cm 4, every 2 cm 4, that which is 8, like that. Keep adding 4 as you move on. Of course, then you must ensure that you plot your graph. Let it be 2/3 or more than 2/3 of your graph. So let it not be that you have a graph from here to here and then you plot one tiny stuff somewhere. Because, oh, you say the values are very tiny, the values are very small, and the rest of them. No, it doesn't make any sense. Or you say, oh, the values are too much, so I have to. No. So you have to ensure that at least the graph covers a larger part of the area of the graph sheet. So even though you want to use the whole of the graph sheet, there's no problem. If you want to use the whole of the graph sheet, there's no problem. But sometimes you may have larger values. You try to make it to come down so everything will enter. So that you have a smaller value, you have to increase the scale. I will explain those things, okay? But this is just the beginning part. I just want to cover so many things in this part 2 of the video, okay? So that is one of the things. So now the next thing again is when you are plotting your graph, you must ensure that your line of best fits takes at least the line of best fit is a line that cuts across at least 3 points and maximum of any number of points of your choice. Okay, so if I have this, then I should have about 3 points or more than that I'm able to grab. Do you understand? At the end of the day, you get that? So once you're able to grab about more than 3 points, then we are good to go. So that your slope is going to be larger. Your slope has to be big enough to accommodate that. Your slope has to be big enough to accommodate that. Okay. So if you have this, then you have a point here, you have a point here, you have another point here. Now basically it's not a must that you must come here and take that the point here, or you must come and take your line here, your triangle here and here. No. You can take below these points, and take above these points. Let it be very big. It should be a bit large, it will be a bigger or larger than we have there. So it doesn't mean that you must always have points to points. No, I think that's what most students think, that you must be point to point. You can have more than that. Okay, then you have your change in V, your change in I. Then you go over to take your scale. The next thing again, before I round up the video, just a 10-minute video I want to make, is your slope. Your slope. In case you are asked to find, of course, you must experiment, you'll be asked to find your slope. So in case you are asked to find your slope, what then do you do? So now the question is, getting the slope is not the problem. Okay, like I've said, I'm going to do a practical video on taking your slope. Your slope must get the units, because they will ask you what does the slope represent. For example, if I'm plotting a graph of V against I, okay, if I plot a graph of V against I, what does my slope represent? V against I will give me I. So that means the slope of that V against I is what? The resistance of that material. Of course, if I plot a graph of I against V, I'll have 1 over R, which is what? Inverse of resistance, which is what? Conductance. So, and then when you write the correct units, the correct slope, it was able to estimate the unit of that slope. And from the unit of the slope, that is when you now know the significance of that slope. So these are things I want us to know. Okay? Because they are going to ask you some questions based on what you get. Then of course your intercept. The intercept is where the line cuts on the axis. So if I have a graph like this, I'm aligning front here. So whatever you have here is your intercept. You get that? So these are some of the things I want us to grab so that you don't miss out in some of these things. And of course, another thing again you'll be doing is the question they'll be asking you, you answer them accordingly, because we have short answer questions that will be asked, then precautions, and then other stuff like that, and then some calculations that will be given to you to do and at the end of the graph work, or based on the graph work, or maybe from the graph do these calculations. So you have to follow up that. So once again, this is part 2 of the practical physics concepts and what we need to know for the second semester. The next video I'll be showing you the practical to be done for the semester. I'll be going through them like I said, and then I will be showing you practical way how you can plot graph, okay, and then some things you need to know in each of the graph. Of course, each of the experiment, I'll be discussing each of the experiment one after the other. There are very many of them. I'll bring them together, basically like I said, optics and electricity. I'll bring them together and give you full concepts about that. But before then, I'll be giving you full concept on electricity experiment and full concept on the optics experiment. So get more video, you expect more videos from me this second semester, okay? Last semester I started very late, and by the grace of God, I say thank you once again to over 149 subscribers so far as I'm then. I know that more are coming and more are still hitting on the subscription button. Thank you and God bless you.